Welcome to Get Your FRQ On. This question is from 2016. It's question 1, and it is calculator active. In the question STEM, we have water being pumped into a tank at a rate modeled by a function W of t. T is measured in hours. We also have water being removed from the tank at a rate modeled by a function R of t in liters per hour. Where R is differentiable and decreasing, and selected values of R of t are presented in a table. At time t equals 0, we are also given that there are 50,000 liters of water in the tank. In part A of the question, we are asked to estimate R prime of 2 and to indicate units of measure. R prime of 2 can be found using the average rate of change formula for t equals 1 and t equals 3. And so R prime of 2 is equal to R of 3 minus R of 1 over 3 minus 1, which is 950 minus 1190 all over 2, which is negative 120 liters per hour. In part B of the question, we are asked to use 4 left-hand Riemann sums to approximate the amount of water removed over the 8 hours, and then to determine if this is an over or underestimate and to provide a reason. So using 4 left-handed rectangles, we integrate from 0 to 8 R of t dt, which is going to get us 1 times R of 0 plus 2 times R of 1 plus 3 times R of 3 plus 2 times R of 6 from the table. This is going to get us a value for the integral from 0 to 8 of R of t dt of 1 times 1340 plus 2 times 1190 plus 3 times 950 plus 2 times 740. And when you simplify all of this, you get 8,500 liters of water being removed from that tank in that 8-hour period. And lastly, we are given that R of t is a decreasing function, so that means that the left-hand Riemann sum would be an overestimate for this integral. In part C of the question, we are asked to use our answer from B to estimate the amount of water in the tank after 8 hours. The amount of water in the tank over the interval from t equals 0 to t equals 8 hours can be modeled by the following definite integral. The amount of water would equal 50,000 plus the integral from 0 to 8 of Wt dt minus 8,050. Since this is a calculator active question, feel free to use your calculator. The amount of water will be 50,000 plus 7,836.195 minus 8,050, which is about 49,786 liters. In part D of this question, we are asked if there's any time t where W of t equals R of t in that 8-hour interval and to provide a reason. To begin, we're given that R of t is differentiable, so we can conclude that R of t is also continuous. In addition, W of t is continuous, and therefore W of t minus R of t must also be continuous. Using a calculator, we can see that W of 0 minus R of 0 is positive, and W of 8 minus R of 8 is negative. And by the intermediate value theorem, there must be a value of t somewhere between 0 and 8, such that W of t minus R of t is equal to 0, which implies that there is a value of t for which W of t equals R of t on the interval from 0 to 8. Therefore, we can conclude that at this value of t, the rate at which water is being pumped into the tank is equal to the rate at which water is being removed from the tank. If you want more AP Calculus AB free response question solutions, you can subscribe to my channel on YouTube, like each video, and you can also follow me on X at x.com/getyourfrqon.